Welcome to H2K Infosys. H2K Infosys is a e-verify business based in Atlanta, Georgia, United States. We provide 100% job-oriented, instructor-led, face-to-face, true live online software training programs. It also includes access to cloud test lab with software tools. We provide live project for you to work on. We also provide assistance with mock interviews, resume preparation and review, and job placement assistance. H2K Infosys is trusted by so many students across the world. H2K Infosys provides world-class services in IT training with real-time project work for corporates and individuals, special IT training for MS students in the United States, software design, development, QA manual and automation, performance testing and maintenance, IT staff augmentation, job placement assistance, and tech support.
And you are going to return the control back to the caller. Let us say you have opened a database connection or you have opened a file, but because of some reasons you got some error, and you are going to return the control back to the caller. But before returning the control back to the caller, you are supposed to close the connection or you are supposed to close the file. So that means before returning the control back to the caller, if you want to execute certain statements that are necessary, then you can go ahead and place those statements with respect to finally block. This finally block statements, they'll get executed irrespective of exception. If the exception has raised, then also it will go and execute finally block. If the exception hasn't raised, then also it will go and execute finally block. We'll discuss about one by one in detail. So for each and every block, we are discussing about only one stuff, which is exception object. This exception object will be prepared by your JVM. If at all, if the code was not capable of handling the exception, let us go and write a small program. We'll write about exceptions later. com.exceptions arithmetic operation public static void main string args int a comma b now int c equal to a/b. After that, I have one statement which is c value plus c. This is a simple program which consists of only 4 lines. Here we are just taking 2 values, a value and b value. Sysout statement was available. We are performing division, and then we are trying to print the data. We know that this will be going to resolve to a divide by 0 exception, but we are not at all handling the exception here. Let us go and execute the code. So normally the flow of control, it will start from the main method. So it has executed this line, and after that it has printed this line, and now at this line int c equal to a/b. 10/0 we are trying to perform, which will lead to divide by 0 exception. And after that, we have one more statement. The 2 points that needs to be noted at this level is, once after an exception has raised, it won't execute any line once after the exception line. So that means this is the line where exactly the exception has raised. Once after this, the program will be going to terminated and the control will be returned back to the JVM. See, this method was called by your JVM. Whenever an exception has occurred, you can see that this line has printed. Whenever an exception has occurred, there should be a handler for the exception. Currently, we don't have any handler for the exception. When you don't have any handler, for the exception, JVM will be going to use the default handler for exception, and it will be going to handle the exception. So currently the exception, whatever that was raised at this level, is handled by our default handler from the JVM level. The default handler will be going to handle the exception and will be going to print a stack trace. Print the stack trace is nothing but exception message. It will also consist of line number where exactly the exception has occurred, and it will also consist of the entire stack trace, nothing but, let us say you are calling one method, and from this method you are going one more level and calling another method, and from this level you are going one more level and calling one more method. Let us say the exception has occurred at this level. The stack trace is nothing but, see, normally we'll start at the main method. Let us say main method, you have created shape object. From shape object, let us say you are calling print calculate area method. From calculate area, let us say you are calling print data method. Let us say we got the exception at print data level, and you don't have any handler for the exception. So this is the entire stack trace for your exception message, the hierarchy until your main method. So the hierarchy will be going to contain in a reverse manner, which is print data, calculate area, shape method, and main method. The entire stuff is called as print stack trace. It will be going to show you, Java will be going to show you the print stack trace. Currently, this is the print stack trace. What it is telling, exception in thread main, and this is the name of the exception, which is java.lang.arithmetic exception, and it consists of divide by 0 as a message, and after that it will be going to specify where exactly the exception has occurred. Currently the exception has occurred at com.exceptions.arithmeticoperation.main method. And here inside the brackets you can see that it is specifying the name of the file with a colon symbol and then the line number. When you click on this, it will be going to highlight by Eclipse where exactly it is pointing from this level. So by using print stack trace, you can identify what kind of an exception that got raised, and then what is the exception message, and you can also find what is the line number or where exactly the exception has occurred. Let us say we are not handling the exceptions. Sorry, we are not writing the code here, and we are writing at some other method level. So I'm writing a static method, public static void perform division. int a comma int b. I am taking two numbers, and whatever the division that I am performing there, I am just performing at the method level now, and I am calling the perform division, and I am passing a comma b value, and I am taking the value into c equal to. So instead of performing the division at the main method level, I'm just writing at a different method. I just want to verify how the exception will be going to display, or the print stack trace will be going to display now. See, now also it will be going to throw an exception that we already know. But the important thing is how the print stack trace will be going to print the entire stack trace for the exception call. So let us start in this way. Int a equal to 10, b equal to 0. This got printed. Once after that, int c equal to perform division, we are calling this method. When we call perform division, the control will be going to transfer at this level. So that means whatever the main method that is executing, that will get halted, and it will transfer the control at this level. So now it will start working at this level. This will be going to throw an exception, and we don't have any handler at this level. So that means whenever an exception has occurred, it will be going to verify, is there any handler available at the method level? Currently, you don't have any handler at the method level. Once after that, it will be going to verify it at the caller level. What is the caller for perform division? This is the caller. So it will be going to verify, JVM will be going to verify, is there any handler at the caller method level? Who is the caller for perform division? Main method is the caller. Do we have any handler at this level? No, we don't have. What is the caller for main? Ultimately, it is JVM, which means if at all, if there is no handler at your caller level also, it will be going to return it back to the caller, which is your JVM currently, and your JVM will be going to kick off the default handler, and the default handler will be going to print the stack trace. But in this case, the stack trace will be a bit different because the exception has arisen from perform division, but not at the main level. So you can see that here also it is saying exception in thread main, the exception class name or object name, and the exception message. And once after that, it is specifying the exception has occurred at arithmetic operation perform division method level, and the line number is 21. This is the line. And the next line, it is specifying that it has returned the control back to this level, and here also it didn't find any controller, which is arithmetic operation main method 12. So this is the caller. This is the caller line. Caller line number.
Can you just repeat from the place where the JVM will look for exception handling in the main, because it is the caller for perform division. It does not find a handler there. So what it does after that, can you please repeat from there?
Yeah. Whenever an exception has raised, let us say the exception has raised at this level, you don't have any handler for the exception at this level. Whenever you don't have any exception handler at the calling method level, sorry, the caller method level, it will be going to return back to the caller. The caller is currently the main method. Inside your main method, you are calling perform division method. Whenever the JVM doesn't find any exception handler at the method level, it will go and look after at the caller level. Currently, the caller is perform division. Do we have the exception handler at this level also? No, we don't have any exception handler. Who is going to call the main method? Your JVM will be going to call the main method. So once you don't have the exception handler at the main method also, ultimately it will be going to return back to the caller who is our JVM. So when the JVM receives the exception related stuff, it will identify that user classes are not able to handle the exception, and it will kick off the default exception handling mechanism, and it will print the stack trace. But current case, perform division, which is at the inner method level, and it was not able to handle the exception at this line. So it has displayed that particular line. The next level, it will go and verify the caller level. This is the caller level. Do we have any exception handling for this line? No, we don't have any exception handling for this line also. So that means it will be going to specify that, yeah, here also it was not able to handle the exception. What is the next level? The next level is the caller for main method. Who is the caller for main? Your JVM itself. So the exception is returned back to your main method, and your main method starts the default exception handling mechanism. Is that fine, Soumya?
Thank you, Krishi. I got it.
Now, we'll take a look at how to handle the exception. But before that, we need to know the hierarchy of exception handling classes. From now onwards, we'll be going to learn the API of exception handling classes. See, until now, we have seen all the basic concepts, and from now onwards, we'll be going to see how to apply those concepts. How to use superclass reference to subclass objects, how to make use of interfaces, references, and call the subclass objects, and how to make use of dynamic method dispatching, and how to apply overriding concepts. So whatever that we have discussed, you'll be going to see practically with respect to these APIs now. Not only exception handling, what are all the next classes that will be going to cover, like threads, IO streams, collections. All those APIs, whatever that we are trying to learn, those are all entirely defined or entirely depend on the concepts that whatever that we have learned. Exception handling hierarchy. On the top, for every class, what is the subclass? Sorry, what is the superclass? Object class is at the top level of all the classes. Even if you make use of any of API classes, those are also derived from object class only. Currently, we have mentioned that for each and whenever you are going to try some of the statements, or whenever you have a block of code from which there might be a chance of raising an exception, you'll be going to specify that in a try block, and you'll be going to catch an exception object. To prepare an exception object nothing but you are going to create from a class. So Java uses certain classes to create exception object. There are plenty of exception classes available. You just need to know some of the classes, or you just need to remember the high level classes that are going to use for your exception objects. So for that, you need to know the exception handling hierarchy. Throwable is the root of all exception classes. This was extended by two separate classes, which are exception and error classes. Exception used to create custom exceptions, and errors, these are not supposed to be handled. Errors, the exceptions of type error, we are not supposed to handle these exceptions. This kind of exceptions, error kind of exceptions, they will occur because of, take two scenarios. The first one is stack flow error or out of memory error. So these kind of exceptions we are not supposed to handle at all, because this needs to be taken care by the admin people whenever you have out of memory. Out of memory means you are not able to allocate the memory for the objects, which means you are supposed to increase the size of the JVM. So you can't handle such type of errors within your code. So these kind of exceptions, they are branched under error type, and exception, this is the first branch which consists of all the subclasses of exception, and this is the class which you will be going to use to create a custom exception. Exception class, again subcategorized into checked and unchecked exceptions. These are just subcategories, they are not classes. Checked exception and unchecked exception. Whenever, let us take a look at the diagram. See here, java.lang.object, which sits at the top, and the next level is your throwable class, which is our root for all the exception classes, and throwable is branched again into two parts. First one is exception, and the next one is error class. And under error, you can see that I have mentioned only one. There are some other classes also under error class, but it's not required for us to bother about error class related any of the subclasses also. We are only bothered about exception class and the subclasses of exception class. Again, exception class was divided into two categories. The first one is checked exception, and the next one is unchecked exception. Checked exception is nothing but the compiler will be going to verify, and it will be going to complain if you are not handling those exceptions. That means, let us say you are accessing some streams. Streams means you are accessing some files on your local disk. So the file might available or the file might not available. If the file not available, then your JVM will be going to throw an exception. So that means when you are trying to access the file, your JVM knows that the file might available on your system or it might not available. So in that case, that particular code has to be handled with a exception block. If you are not handling that exception block, your compiler will be going to complain that you are not handling the checked exception, which is IO exception, and your compiler will not allow you to compile the program. Checked exceptions are verified at compiler level. The next one is unchecked exception. Unchecked exceptions, or you can call them as runtime exceptions. Just now only we have seen about one small exception, which is arithmetic exception. This arithmetic exception is occurred because of data. There won't be any flaws from the code. So these are occurred because of runtime. If you pass the data correctly, 1025, there won't be any issues. If you pass the data as 10,0, then you'll be going to get an exception. So these kind of exceptions are unchecked exception, which means the compiler won't bother about these kind of exceptions.
So many of our students have given testimonials on how our training programs are. You will find them on kudzu.com and on our website h2kinfosys.com. On our website h2kinfosys.com, you will also find more detailed information on who we are, the courses that we offer, what each course covers. Also, if you're interested in a demo program, please register on our homepage on the left-hand side. Just give us more information about yourself and we will send you a link for a demo class. The demo class is absolutely free. Experience our commitment by just attending an orientation workshop at no cost. Our team of faculty and advisors are here to guide you with the right information. If you still have more questions, please feel free to call us. Call us at 770-777-1269. This is a United States number. If you're calling from the UK, call us at 020-337-17615. You can also email us at training@h2kinfosys.com or h2kinfosys@gmail.com. Thank you for watching our videos. We wish you a great career in information technology.